Everyone, welcome back to Garage Science. So this is going to be a little bit of a different video. I'm going to not do like a full in-depth review, but kind of a 2.5-year after-the-fact overview of the Tormach PCNC 440 that I purchased back in 2022. So this mill's had a lot of hours on it. Probably not as much as other mills after they're 2.5 years old, but for the size of mill it is, it's definitely had its fair share. So I'm going to go over some things and things I like, things I don't like, just general overall performance of the machine, and let's get started. Now when I talk about having my fair share of use on the machine, I can definitely say this little machine's made its fair share of chips. So all that's aluminum. I still need to take it to get it recycled, reclaim some of that material. But yeah, this machine has done quite a bit of milling. Now looking on the inside, you can see that there's still chips everywhere. I actually just got finished using this a couple hours ago, and yeah, did have pretty good amount of use this morning, and I am pretty satisfied with getting the enclosure and the chip tray. Definitely keeps the shop cleaner. As you can probably tell from the bucket of chips, all those chips would have been on my shop floor and around everywhere. What you can see here on the bottom is I put a piece of angle iron here at the bottom as sort of a dam for the chips, so they would pile up over here and not by the drain for the flood coolant. And then what you'll see here is this blue cage mesh looking thing around the drain, and what that's meant to be is a sort of pre-filter for the chips, so that way the larger chips don't pile up on top of the screen and just immediately clog it. So what that allows the mill to do is to run longer before you kind of have to sweep the chips away from the drain, and so the coolant drains well. And so that was an after the fact thing that I did after I tried milling for long periods and just constantly had to stop and sweep the chips away. You guys will notice over here on the side I've got these arms mounted here. These are the tool holding forks. It's a busted detent arm. That's the old carbon fiber PLA version, which I don't make anymore, and so I still got to replace that. But these tool holding forks allow me to put tools in here. If I'm doing a manual tool change, I can take the tool out and slide the tool in, and then have the other tool that I want to put in already sitting here, and then put it in, so you don't have to like hold the button and juggle tools while you're trying to do a tool change. So that's handy. But yeah, doing pretty well. No real complaints. Oh, and then a few other things on the front of the machine here. So I added a piece of U-channel aluminum, and that acts as a chip chute for coolant and chips that spill over the front of the table. Instead of building up on the bellows area, they'll hit the chip chute and roll down the side and then dump off the side of the table. That keeps it off of the bellows, and then the bellows on the front of the machine at least has this rubber cover that will allow the chips to hit and fall over the side and roll over the side. This extends past the bellows by a couple inches. I basically kept having an issue where the chips would fall on the bellows and then get between the bellows where they wouldn't compress properly, and then the bellows actually would bunch up and pop out of the track. And I've got a video on that, you guys can go watch it, but this keeps the chips from building up on the bellows. So pretty good little improvement. I kind of wish Tormach would produce the mill with it, but anyways, it's not bad. It works pretty good, no complaints. Now on the top right part of the column, I've got this manifold up here. This is something that I made, and it's a coolant manifold. So normally the flood coolant system comes with a flexible coolant nozzle like this. There's a bracket that mounts to the back of the spindle Z column, and then the flex hose connects to that, and so you get one nozzle that sprays coolant down to flush your part with coolant. And that's okay, but I was again trying to increase my productivity, and so having multiple nozzles going at the same time, and then also having them higher up, so that way you get more of a downward angle on the part. And then also, because the Z column's not very high on the PCNC 440, if you're trying to set a fixture up on the table and you hit it with a dead blow hammer or something like that, like you're actually close enough to the top of the spindle where you might actually you know, bump your coolant nozzles, and then, you know, you got to readjust them and all the rest. So having the coolant manifold up like this keeps it up and out of the way. You get more sort of a 180 degree coverage, close to 180 degrees coverage of coolant on the tool. And there's 4 nozzles instead of 1. And I've also got the nozzles with a smaller diameter nozzle on it. And so the spray is actually pretty high pressure, and so you get better chip clearing also. So pretty happy with this upgrade. Again, I've got another video on that. You guys can go check it out if you're interested. But this was a good time investment. Now at the back of the machine I have this 3D printed guide. And what that is it's a guide for the flood coolant hose. And it basically just allows a path of travel for the coolant hose, so that way as the spindle head moves up and down, this hose can't somehow find its way moving forward. It can't get in the way of the tool or any tool changes. It can't get caught on something on the fixture. It just stays out of the way. And so that was a pretty simple little upgrade. And so that just defines a path of travel for the hose as the spindle moves up and down. And again, I don't really know if any of those scenarios are really possible, because when I was setting the mill up, I saw that and I just didn't really like it, so I printed it. It was pretty easy. And then so I've never actually run the mill without it, so someone can maybe leave a comment if they've ever had an issue with that. But that works pretty well. Okay, so getting to a little bit more nitty-gritty here. The one, I guess, probably gripe that I would have long-term about the PCNC 440 is what I recently, sorry, got my focus messed up here, is the connection for the X-axis stepper motor here. You'll see I got a bolt zip tied to the side of it. So last week I discovered this flexible conduit here had torn right at the nut, and was basically kind of like leaning off. You could, you know, see the wires inside and everything. And I disconnected it on the other side and took the air compressor to it and blew air through it, and then it was just a fountain of coolant coming out of the hose. So there's been coolant and probably chips building up inside this conduit. And that's, again, the conduit for the electrical to the X-axis stepper motor. And so this conduit was flexing from the table, moving back and forth, up and down over the last 2.5 years, and it eventually tore. And so wasn't too pleased to discover that, because I, again, didn't realize that it happened. And so who knows how long I ran the mill with it like that. One thing I did do was just zip tie a bolt here. It's not you know, super precise solution, but all it does is it stiffens this section of the conduit just a little bit, so that way it doesn't make such a harsh bend when the table moves back and forth. So it should spread that stress out just a little bit, so that way the conduit doesn't tear here again. If it does, maybe I need to just replace the conduit, but we'll cross that bridge when we get to it. But yeah, not a huge failure, but and there's been no issues electrically with the mill. So the stepper motors run fine. There's been no change in performance. So just something that I was a little annoyed by. Now on the doors here, you can see I've got this rubber strip here. This is a sealing gasket for garage doors, actually. And so I put it on the bottom of the door for the enclosure because the drips on the bottom of the door were actually rolling out of the enclosure when I initially set the mill up. And so I put this gasket here to keep the drips from being on the front of the door and kind of rolling forward, as if they would kind of be deflected back, and that seal presses up against this bar. It's on the bottom of the enclosure. and so the seal presses up against here, and so it keeps the coolant, rolling back into the enclosure instead of potentially rolling forward out of the enclosure. So that was a small thing, but it keeps the shop floor a lot cleaner. The other thing, and I don't know if maybe Tormach's changed this in their instructions or in their installation guides, but this this door flap here, okay, there's an edge here to the left door, and you screw it on when you get the mill. So there's a screw here, and there's a screw on the top up here, and then it's also held on by the door handle. So you screw it on, and then what I noticed almost immediately after I installed the door and tried the coolant out is the coolant will seep under that edge, and because coolant has kind of a milky white color to it, is the whole front of this would be sort of a milky white opaque color, and so because of that you wouldn't really be able to see through it, and I didn't like that. So what I did was I took it back off and I put clear silicone underneath this edge, and so it seals it out, and then it also keeps physically keeps liquid from intruding into there, and then it dries clear so that way you can still see through it. So that's worked out really well. I've had no issues there, but that is kind of a small thing. And then the last second to last sort of thing that you can see on the front of the mill is I've added lights to the inside of the enclosure. So let's see if I can get a shot of those. So I've got these LED strips that run the left side and the right side, and then on the front there's a strip here, and then there's another strip here, and so you get kind of a forward and then down kind of angle of your lighting, and so you get really good view of your work area at the table, and then what all that is wired to is a switch up here on the top, which is you can see very professional looking, and pretty simple. It's got 12 volt cheap Amazon laptop power supply running it, so pretty simple little improvement. These strips have adhesive on the back, but I didn't use that. I printed these PLA kind of brackets, and they come up and screw through the top of the enclosure, and so that just keeps the coolant from degrading the adhesive and making the light strip fall. It will hold it up there long term, which it has. These strips have been up here for at least 9 months at this point, so have had no issues with that. Very pleased. And then you can get a shot of the strip on the inside. Okay, so not bad. Okay, so the last sort of change that I've done on the mill is this. I call it a sneeze guard, but really it's just a Chip Deflector / Coolant Deflector for the tool changer. So on most Tormach machines, because your Z column is quite a bit higher, you probably don't deal with this, but because the tool changer is so low in relation to the table, that there's a lot of splash and chips that kind of go directly this direction. And there's a cover here for the carousel, so you don't just have chips flooding the top of the carousel, but it's not airtight by any stretch, and so I've had some chips still collect up here, and so I put this this polycarbonate deflector here, and that's going to be one of the subjects of this video. Is I'm actually going to replace this deflector I made by using a blowtorch on some polycarbonate and wrapping it around an old an old 3D printer filament plastic spool, and so it was a non-ideal solution to begin with, but you can see over time there's been cracking and there's been a piece chipped off here. The coolant sort of did a number on the polycarbonate, so I've made another set. I'll get that out here in a second and show you guys where we're going to mount it in here and replace this. And I think there's a pretty good upgrade if you do a lot of milling and you use the tool changer. Is it allows you to cycle that tool changer a lot, and I've not dealt with chips building up on the top of the tools or the top of the carousel. So yeah, we'll do that here in a sec. All right, so this is basically the jig that I made to make the polycarbonate deflectors, and so it's just 1/2 inch plywood cut into 9.5 inch diameter circles, and then, you know, to go through less material, I put 1/2 inch spacers between each of them, so they're, you know, instead of it being a solid roll, it's it's spaced out. Worked pretty good. The polycarbonate, the way I formed it was you put it in the oven at 325 degrees for about 8 to 10 minutes, and at that point it gets really soft and malleable, and so you take it out really quick, lay it over the top of this, and then just with gloves or a piece of wood or something, form it around the edges of the former here, and wait for it to cool. And it's really simple. It takes about 10 to 15 minutes to do the whole thing. And yeah, so I'm gonna keep this because I don't know, maybe I'll still have crazing after a while. The sneeze guard that I have up here has been up there for about at least 9 months, so it did last a while before it kind of started falling apart. So I think having formed it properly, I think it will last even longer the next time. Okay, so got the old chip guard off, got it wiped down, cleaned up a little bit. This is the new one. So this is 1/8 inch polycarbonate. Got it from Home Depot, nothing special. Like I said, I formed it around that wooden form at 325 degrees after having it in the oven for at 325 degrees for about 10 minutes. You'll notice it's a little opaque. That's not from going in the oven. I sprayed it with a clear enamel spray paint, and that should hopefully protect it from crazing also, because it should keep the coolant off of the actual polycarbonate. It's also, that spray paint was about 10 years old, so we'll see if that finish holds up. But the old ones, you can see here, pretty well broken up, and some of the pieces have actually chipped off. Okay. And again, this one was just like barely held together. I can just like break it off. So it needed to be replaced. The carousel itself stayed clean and free of chips, so that's the whole purpose of the chip guard to begin with. So we're going to go ahead and mount it, but the holes aren't particularly spaced very well, so I gotta kind of hold it up here and mark them with a marker and then go and drill them. But I am going to mount this slightly higher than the last one, so that way it makes sure that it clears the toe clamp studs, and then we're going to change up how we mount it just a little bit, so that way hopefully it lasts a little longer. But this is 6 inches tall, and this particular piece is 12 3/4 inches long, so it wraps pretty much halfway around or just about halfway around the carousel, and you can't wrap it all the way around because the door has to be able to swing open to mount the tools, and so because the posts for the nuts stick out a bit, then the door won't be able to open if you wrap it all the way around. And I didn't want to put a countersunk screw in the plexiglass, because now that countersink is going to distribute a lot of stress radially on the the polycarbonate, and would probably cause crazing, so we're not going to do that. So same as the other one, we can't wrap it all the way around, but that's fine. Apparently, because that's the way that I had it before and it worked fine, then it doesn't need to wrap all the way around. Okay, so we've got this ready to go in. The holes are drilled. Just want to go over how I'm going to mount this because it's different. Last time I just had a screw, countersink screw on the other side, poking through with a nut on it, and as you guys saw, that had a lot of crazing associated with it. So this time I made the holes bigger, and then I have these little rubber washers that we're going to slide in here, and what they're going to do is they're going to go into the hole and act as dampeners for the polycarbonate. Okay, and then when I screw that down, that'll kind of squeeze the rubber out, and so this whole thing will basically be mounted on rubber. And so what that should do is, as the machine vibrates from the cutting, then those vibrations won't really translate into this cover so harshly and potentially cause cracking. So that's how we're going to mount it, and hopefully it lasts longer that way. It should also seal out some of the coolant around the inside of the hole, and then we're also going to seal the top of this with some silicone so coolant doesn't seep in from the top around these holes. So that should hopefully keep it lasting a little longer also. Alright, so the new chip deflectors are installed. So actually look pretty nice. Like I said, I coated everything in a clear enamel spray paint, so I think that will keep the coolant off of it and keep it from cracking. These are M3 screws, but they're going through a 1/4 inch hole, and then there's rubber washers inside the hole around the screw, so it sort of acts as a dampening element in there, so that way as it vibrates it shouldn't crack like it did last time. So it's also formed closer to the actual circular shape. Unlike last time where I did it with a blowtorch, it was very uneven and I kind of had to force it to curve around the side, and over time that bending stress combined with the chemical stresses from the coolant just cracked the living tar out of everything. So I've already put silicone on the top of this, and it's mostly dry, and then I just put silicone here. It's white and will dry clear, so that should kind of keep coolant from just seeping in between here constantly. So hopefully that helps. But anyways, it runs just fine. One thing I did want to talk about, because I mentioned before about one of the tool forks on the front of the mill enclosure having a broken detent arm, and so those are that broken one was a PLA carbon fiber detent arm that I no longer use, and I just haven't replaced those ones yet. The PLA seems to get embrittled by the coolant, and so these are all nylon carbon fiber, and nylon's about as chemically resistant of a filament as you can use. And then these are all printed with 100% infill, and the cool thing about nylon is you can anneal it. So all these have been annealed, makes them about 40% stronger. But if it ever happens that these arms bend permanently out of line, then you can actually take it off the tool fork, put it in the oven at about 170 degrees, and re-anneal it back to its original shape, and it's basically the same exact condition that it was in originally. So these are much more durable arms, and if you haven't seen my Etsy shop, I do sell these aluminum tool forks with the carbon fiber nylon detent arms. So that's on my Etsy shop. I'll put a link in the video description if you want some, but these are great, way better than the standard tool fork. I can pull one up. So this guy, these just they don't stay flat super long, and they don't hold the tool in quite as tight as these tool fork arms, and so these won't deflect. And anyways, it's a lot nicer, so I like these. But we're gonna go ahead and remount this up into the top of the tool changer, and then reload our ATC with tools. Okay, so the tool tray is loaded up. I'm going to go ahead and slide it forward here. Okay, and so this piece on the back, okay, that's the moving chip guard for the door on the front of the ATC, and so that's why you can't wrap this all the way around. You know, if you did it just right, you might be able to get it to where they overlap with each other without having too much of an issue, but there's no real reason to have this wrap all the way around because most of your chips are coming at it from this direction, so this ought to be enough. But we'll go ahead and load a tool up. Easy peasy. Now, on the subject of the tool changer, I love the tool changer the way that I have it right now. It's taken some finagling to get it adjusted and set up just the way that I want, and sort of figuring out little things that I can do to improve it. Things like the chip guard, things like the tool holding fork upgrade, and little things like that have made a big difference in terms of how well and how reliably it performs. But I've gone close to 2 years now, year and a half at least, without a tool misfeed by going to the upgraded tool holding forks, and so I couldn't be happier about that. There's a few things that are just important to keep in mind and to check occasionally. You definitely want to use a tool like this occasionally in your tool changer to make sure that you're still perpendicular or normal to your mill table, just to make sure that you're feeding properly into the mill. And you know, that's just you know, good practice to check occasionally. And then this bar up here, and get chips on it occasionally. The bushings that are on the gantry for the ATC have little slots in them, so that way if there are chips there that it doesn't just grind away at the bushing surface. But it's good to wipe that occasionally. But all in all, you know, you keep your air, lube oil cup full, and the tool changer will just run and run and run and run and run. Now, one advantage you have by dialing in the tool changer is it makes it so that way the wiggle room that you have between the spindle and each of the tools in the ATC, you don't need as much wiggle room the more dialed in your tool changer is to your spindle head. And if you have it like that, then what you can also do is something like what I've done, where I added a washer to the stack up for the spring on the spindle. And so what that gets you is the top of your spindle bolt, collet bolt. You know, this bolt goes all the way through and connects to the collet inside the spindle, gets it closer to the cylinder for the power drawbar. And so what that ends up getting you is more force being exerted here during normal operations when you are holding your tool in, and so that gets you more holding force on your tool. So the Tormach tooling system does have the ability to pull the tool out of the spindle if you're cutting aggressively enough. And so you kind of got to watch that and do the regular maintenance on the power drawbar to prevent that from happening. But being able to do this also lessens the likelihood that that'll happen, and so it's a great little thing to do to just increase the reliability, make sure your tool's not going to pull itself out of the spindle due to the cutting forces. If you're getting a lot of chatter while you're cutting, it's a higher likelihood that chatter is going to result in the vibrations right from the chatter is going to result in that tool getting pulled out of the spindle. So if you get one of the bigger Tormach machines, they have a BT30 spindle option, which it'd be cool if something like that was available for the 440, but it's a pretty small mill, so I can see their reasoning in not having that. But yeah, if you dial in your tool changer, then you can do this, and it'll increase the holding force, because basically what happens is the stroke here to release the tool is lower, and so the collet, when it sort of releases the tool, is it doesn't release it as much, and so like I said, the wiggle room between the tool and the collet is less than it would be otherwise, and so your tool changer has to be really dialed in to be able to do that. But anyways, not had any issues by doing this. I probably wouldn't stack up more than this, because otherwise you're not going to have much travel, period, with your power drawbar, and you're sort of pushing the limits as it is. But this is a washer that actually was part of the packaging for the mill. It was bolting the mill to the pallet when I received it. So for all you hoarders out there, don't throw all your stuff away. You will find a use for it. Now for the back of the mill, let me go over a couple things that I've done. So this is the back panel for the tool changer. I did have an issue with the air low pressure switch. I don't know if it necessarily went bad or maybe just the setting drifted, but basically I was getting the low pressure warning in Path Pilot, even though my air pressure was plenty high enough, and was preventing the tool changer from working properly. So that pneumatic switch is behind that panel, and so if you ever need to swap that out, it's behind there. I've got another video of me going through that and how to do it. Air switches are pretty cheap, so if you ever run into that, it's not difficult to overcome. And then something I added when I did the swap out for the pneumatic switch is this air tank, and this is on the regulator side. Alright, so there's the air regulator. It's on the regulator side of, or on the mill side of the regulator. And what that does is it gets me a volume of air that's at the pressure for the mill. So when you do anything with the pneumatics on the mill, right, either do the ATC or the power drawbar or whatever, it's drawing it out of this tank, and that's preventing the air pressure in the lines for the mill just rapidly dropping, you know, prior to the regulator opening up and supplying more air, right? So that sort of instantaneous drop in air pressure in the line is prevented from this by this tank. And so the idea being that the pneumatic switches in the tool changer, right, if the pressure in the line goes down, that switch will actuate, and then it'll immediately unactuate, reactuate, whatever, once the regulator opens up and supplies more air into the line, right? And so anytime you do anything on the mill then is that switch is doing one of these numbers, opening and closing constantly. And so by having an air tank on the mill side of the regulator, is those fluctuations in pressure won't occur, and so you won't be overcycling your components. So maybe it's overkill, but that's literally the story of my life. So it's what I've done. Alright, and then the last thing we'll cover is this wire here going down into the cabinet. I'll show you what that's for next. Okay, so taking a look in the cabinet under the mill. It's a little dark, but you can kind of see it. I've got a box of spare parts kind of pushing the hose down to keep the coolant running into the tank. So there's spare holes in the cover for the coolant tank. Not sure what they're meant for, but maybe it's for the oil skimmer. What I've done is taken these LEDs and screwed them into these covers, and this is an ultraviolet LED, and it's connected to a current sensor that is hooked up to the power line for the flood coolant system. And so what that means is when the flood coolant turns on, these LEDs will turn on. Alright, so we can maybe give that a shot here in a second. Okay, so we're going to turn the flood coolant on. Okay, you can see the current sensor senses the current powering the pump, and there you go. So you got ultraviolet light. So someone can tell me in the comments if this is even going to do anything, but it's something I just wanted to try. Usually I swap out my coolant every like 9 to 10 months. It actually lasts a while before it starts to... Alright, got interrupted by the air compressor there. So yeah, someone can comment in the comments and tell me if they think this will do anything at all. The idea was just to kind of sanitize the coolant and prevent bacterial growth in here by just constantly having a barrage of ultraviolet light going into here, just constantly killing whatever bacteria might be growing in there. And so maybe that'll do something, maybe it won't. The coolant usually lasts about 9-ish months before I have to swap it out, but this seems to work so far. But these have only been installed for, I don't know, 3 months or so. So let me turn the coolant off again. So the other thing that I did here, and if you remember when I was talking about the nozzles for the coolant manifold, is I used smaller nozzles so they would work at a higher pressure. And I'll show you that here in a second so you can see. I've got a video of me making it, but I'll show you those nozzles in a second. But because those nozzles are so small, the flood coolant pump can pump chips up, smaller chips up through the coolant line, and those chips can get stuck in the nozzles for the flood coolant. And so to prevent that from happening, what I have, and I'm not going to pull it out because it's a bit of work to get to it, is there's a mesh screen, a fine mesh screen inside the coolant tank before you get to the coolant pump. So all the coolant that comes into the tank has to flow through that screen to get to the coolant pump. And so any chips that end up in the coolant tank can't get sucked up by the coolant pump unless they're extremely small, in which case they'll still go out the nozzles and the inside the mill enclosure. So those the sort of changes, improvements they've done in here. I'm still happy that I got the flood coolant system. I haven't cut very much steel. I haven't tried to do stainless steel yet. Most of what I cut is aluminum, but still glad I got the flood coolant system. It's yeah, I think it allows for a lot of options still. So. Alright, I'm going to let you get a look at the flood coolant system. So, pretty good coverage around the tool, pretty high pressure flow, does very good in chip evacuation and tool life and all the rest. So, I'm pretty happy with that project. And it's nearly 180 degrees coverage around the tool, so not good enough for... not 360 degrees, unfortunately, but that would unfortunately, if you did try and do that, would probably inhibit the movement of the tool changer to come in and change tools. So it doesn't have that, but I don't know, maybe I'll come up with some way of doing that in the future. But not bad. Alright, so that's the mill and all its little changes. I've taken the bellows off before and cleaned the ways, but I've not had any wear issues, no bearing issues with the spindle, no issues with the steppers. In fact, the steppers even worked even when they were full of coolant. and yeah, so the machine has endured quite a bit. I just kind of keep tweaking it to make it more the way that I want it to be. But all in all, I am very pleased with this machine, and it has worked so hard. And so let me start showing you guys some of the stuff that I've done. Okay, so let's go through some stuff here. Some of this stuff is kind of end-use parts. Some of it's fixture related. So I guess it was a fixture to hold the tool holding forks actually for a while, and I actually had it set up to where the teeth, the Talon grip teeth on a Mighty Bite set of ice jaws would actually, once I set the position basically of these teeth marks, I would just keep putting it in the same teeth over and over again, the same position, and so that actually got me some pretty good repeatability. But I've since graduated to a better set of soft jaws. This was a component for different project, and so had quite a few operations associated with it. So top and bottom, had these notches in the side, holes in each of the 3 sides here, and so multiple operations, and turned out pretty good, very nice. This was a shaft coupler, and so I had this, I'm guesstimating this had a concentric accuracy of less than half a thousandth between the shafts that it coupled together, and so it turned out very nice. But yeah, actually, and that was without using a reamer. So if I was doing this again, I'd probably use a reamer to get the holes even more concentric, but this was just using an end mill, and it did a very nice job. So pretty happy with that. And on the subject of small stuff, this was, I forget what I did wrong with this one, but this was a failed part I was trying to make, and it's got some pretty small features in here. See if I can't focus on it a bit. So all those ledges and stuff in there they're supposed to be in there like that, and then there's, if you saw the rest of it, if it was done right, then you machine away the top, and then there's even more features on the top that need to go in. But this turned out pretty nice. The one I got right is elsewhere, and I can't show you that right now, but it turned out pretty nice. This was a failed attempt, but still a pretty nice part, and it does have some pretty accurate features on here, so I was pretty happy with that. Back in the fixture realm, so this was a set of soft jaws, some pretty simple features on there, but that was for making a specific component that I needed. And yeah, actually, come to think of it, I'm trying to think of what this was for, and I'm drawing a blank all of a sudden. But yeah, this was a set of soft jaws that I made. And one more set of soft jaws. Oh yeah, this is these are the soft jaws I actually use to make the tool holding forks as they currently sit. And so basically what I did is I incorporated the Mighty Bite Talon grip inserts, and so that way you can grip the raw stock, and then once you're ready for your second operation, it will sit in the pockets. And so that has been an excellent way of doing a first op, second op on these soft jaws. So I'm very pleased with that. And getting away from the aluminum or metal machining sort of side of the house, I've actually done tile engraving on the mill. So I've got a video on that. It's a bit of a longer explanation. Don't freak out. I don't have tile dust inside the mill enclosure, but I did come up with a system to engrave tile without doing that. And so I've done a little tile milling, mostly just goofing around. This was pretty early in my ownership of the mill, so I was kind of goofing around to see what I could get away with, but these turned out really nice. And so yeah, so I've done quite a few projects, done some individual projects for various people, since I own a mill. It's sort of like owning a trailer. So I've been trying to help people out with their projects also, but I don't have those parts to show you, unfortunately. But all in all, I've been very effective with this mill. I'm very satisfied with it. It's been a very useful tool in the shop, and even though it costs as much as a small car, I would not go without it at this point in the shop. It has been extremely necessary. I thought about getting a manual mill way back when, and thankfully God blessed me with the most amazing wife ever, and she was like, well, why don't you just buy a CNC mill? And I thought, well, great idea, dear. I will buy a CNC mill. So that was back before interest rates were crazy high, so it wasn't as big of a deal to finance. But the mill has done great. It's paid a pretty good percentage of itself off just through the tool fork sales. So it's been a godsend in the shop, and couldn't do without it, and I love it. So yeah, anyways, well, I think that's it. it's a pretty good overview of the mill. 3 years in, or 2.5 years in, and it's I would never go back. Definitely would never go back. And so let me know what you guys think in the comments, or if you guys got questions about how my mill has been doing, and I will try and answer them. But thanks everyone, thanks for watching. Make sure you check out my other videos, and we'll see you next time.